Section 3.9, which is our last section in Chapter 3, is on Lewis acids and bases. And in general, for most of the acids and bases that we deal with in organic chemistry, we're going to be able to use the Bronsted-Lowry definition, and it's going to work just fine. But it's still important for you to understand the Lewis acid and base definitions, because every once in a while you're going to run into a situation where the Bronsted-Lowry definitions don't work, and it's going to be important for you to need to know this. So in Gen Chem you were probably exposed to Lewis acids and bases, maybe not, because sometimes it doesn't get fit in. A Lewis acid is defined as being an electron pair acceptor, and a Lewis base is an electron pair donor. And this can be a tricky concept for students to get the first time around, because in the Bronsted-Lowry method, the acid is the donor and the base is the acceptor. However, in the Bronsted-Lowry method, the acid is donating a proton, a positively charged thing, and the base is accepting a proton, positively charged thing. The Lewis acid and base definitions are essentially reversed. So instead of donating a positively charged species, the acid is accepting a negatively charged species. And the base, instead of accepting a positively charged thing, it's donating a negatively charged thing. So it's doing the opposite. We're going to look at a reaction that we've already looked at when we were talking about the Bronsted-Lowry definitions with ammonia and water, which we know to be a base and an acid in this particular context. And we looked when we were talking about the Bronsted-Lowry definitions, we saw how the proton from water is transferred over to ammonia to make ammonium. And then when we learned about using curved arrows, we saw how we're going to think of this. We're not going to think of it as the proton getting up, packing its bags, and moving over to the nitrogen. Instead, we're going to think about it in terms of the electrons. So we're going to recognize that the lone pair of electrons on the nitrogen are reaching out and attaching to the hydrogen atom and forming a covalent nitrogen-hydrogen bond right there. And then the oxygen-hydrogen bond, the electrons in that bond, are going to be relocated onto the oxygen atom as a lone pair. And using the Bronsted-Lowry definition, we know that the water is an acid because it's donating the hydrogen, and the ammonia is the base because it's accepting the hydrogen, the proton. Using the Lewis method, we're going to come to the same conclusion that ammonia is the base and water is the acid, although in this case we're thinking about it differently. So we're saying that the base is the electron pair donor. The lone pair of electrons on the nitrogen are being donated to form the new bond, the covalent nitrogen-hydrogen bond, and that makes ammonia the base. The water molecule is accepting those electrons, and that makes it the acid. Here's another example of another reaction that we can use to help us practice this classification. We have these two molecules that are interacting with each other. We see a transfer of proton from the compound on the right side over to the compound on the left. Here's our product. So there's the proton, and it gets transferred over to the carbon to make this product. So by the Bronsted-Lowry definition, this is our acid because it's a proton donor. Hydrogen's going over to here. And this is our base because it's accepted that hydrogen. If we think about it in terms of electrons, this lone pair of electrons are reaching out and forming a covalent carbon-hydrogen bond, and that's the bond that we see right here. And that donation of electrons is what classifies this particular compound as the base, the electron donor. And the molecule that's on the right side here, our second reactant, this is accepting the lone pair of electrons, which makes it an acid. And the oxygen-hydrogen bonding electrons are being moved onto the oxygen as a lone pair. So make sure that you are slightly familiar with the Lewis acid-base definitions, because they do come up every once in a while, and you want to be able to correctly identify the acids and bases when the Bronsted-Lowry system doesn't work. You can practice this with Skill Builder 312, problems 334, 35, 39, and your study question for this material is, what is the difference between Lewis acids and bases in Bronsted-Lowry acids and bases?